Welcome, everyone. We'll begin in just a minute with Alan Evans's welcoming remarks.
Hello, everybody. My name is Alan Evans. I'm the co-director of EEGNet. Welcome to the EEGNet technical platform launch. This is November 28th, and we'll be spending an hour discussing the technical details of the EEGNet platform, which is now in beta form. I would note that this session is focused on the technical details. In early 2024, we will also be holding an EEGNet scientific colloquium, and that will be headed by Vera Gross lecture. So that'll be more focused on the scientific applications of EEGNet. I'd like to acknowledge the important contributions and support from Brain Canada, the Ludmer Center for Neuroinformatics and Mental Health, and our partner universities at Brock University and Laval University. We will be talking variously today about the partnerships that have been developing on the global scene, most notably the Global Brain Consortium and the NEMAR EEG Consortium, as well as project partners at the Child Mind Institute, the IBIS Autism Network, and the Healthy Brain Cognitive Development initiatives, all of which are using the EEGNet infrastructure that will be described today. Specific goals for today are to present the EEGNet technical platform itself, and then to solicit your input and involvement in providing more data and tools to the EEGNet platform. When the presentations are over, you will be able to ask questions, and please put your questions in the chat, and I'll moderate the answering of those questions. So just by way of a brief introduction from me, the EEGNet network was established about 3 years ago. It is a network of 35 Canadian PIs across 6 provinces. I'm the PI at McGill. We also have co-PIs from the University of Laval, Philippe Albouy, and Brock University, Sid Segalowitz. The premise of EEGNet is that it takes advantage of an extensive IT infrastructure for data sharing and tool sharing. That's part of the Canadian Open Neuroscience Platform. EEGNet is also partnered with the Global Brain Consortium, that you will hear more about from my colleague, Pedro Valdes-Sosa, who's a prof at the University of Electronic Science and Technology of China in Chengdu. And he's also a scientific lead of the Cuban Neuroscience Center in Havana. Just briefly, the overview of the EEGNet network, as shown here, is to develop a unified platform for sharing and analysis of standardized EEG datasets for the national and international research community. And we have a series of outcomes, gold standard, expert annotated open EEG datasets hosted via the technical platform you're about to see, and prepare the data for machine learning applications, clinical applications, and early identification of biomarkers. The aims of the EEGNet have been somewhat delayed because of the issues related to COVID, but we're in good shape in terms of the data platform, open EEG workflows for analysis, data sharing, and analytics. And you'll hear more about these from Christine Rogers in a moment. Again, the Canadian Open Neuroscience Platform, this has been around for about 5 years now. The recent paper has been published in, I forget the journal, I think it's PLOS Compute Biology, but this describes the Canadian Open Neuroscience Platform, which is, as I said, allows us to share data and tools, as well as training and ethics and data governance and oversight of tool sharing and data sharing globally. At this point, we have approaching 120, in fact, pipelines for data analysis, and about 90 different data sets of various forms. what is fundamental to CONP and therefore EEGNet are the twin IT platforms, LoRaS, a multimodal data capture environment, which allows us to store imaging, genetics, behavioral data, biospecimen information, and more relevant to EEGNet, electrophysiology. All of these data can be then processed using the C-Brain high-performance computational portal, which provides access to both supercomputing infrastructure and cloud services. C-Brain is at this point, it started life as an HPC network across Canada, but it now has 3 of the 6 Exceed HPC sites in the US, as well as HPC sites in Europe as part of the C-Brain Commonwealth. So essentially anybody within EEGNet can get access to these resources through C-Brain. C-Brain supports about 1,600 users around the world at this point in 2023. And there are extensive collaborations, which I won't bore you with. So coming back to EEGNet, our deliverables are data and tools to support our user community and to write scientific publications. That's enough from me as an introduction. You will now hear from my colleague, Pedro Valdes-Sosa, who will tell you more about the Global Brain Consortium. Pedro.
Thank you, Ellen. I am going to start my presentation, and to be able to speak about the Global Brain Consortium and why it's related to EEGNet, let's take a step backward and remind you that in 2016, there was a meeting organized at the Global Brain Projects at WHO. This was to analyze the impact of precisely the Global Brain Projects on global health. And the conclusion is that this impact was insufficient. You can see there the participants in this meeting. Now, this later led down the road to a special issue of neuroimaging and global health. I recommend you take a look at this. One of the main conclusions that is summarized from the WHO meeting is in this editorial is that part of the problem is the unavailability of standardized neuroimaging protocols, especially for electrophysiology, that are open source and easily be shareable, and therefore can be applied to disadvantaged populations in any part of the world. As a consequence of this, a number of years later, Alan and I decided to start the Global Brain Consortium. And while not saying that it's limited to electrophysiology, you can see from this diagram that electrophysiology, specifically the EEG, is poised due to its high temporal resolution and also to its cost effectiveness and easy deployment as an ideal interface between multimodal neuroimaging and brain research and applications in public health. So basically, with the creation, you can see here the creation of the Global Brain Consortium. You see the countries that currently are members of the GBC and participating in it. We have started a series of projects that are related to precisely developing tools that are widely extensive. For that purpose, we have organized a steering committee, which you see here, which has representatives from the major brain projects from nearly all continents. And this steering committee is overseeing a series of projects that I will now show. Some of them are related to the application of electrophysiology to specific diseases, but I want to mention one in particular, which is the Global EEG Norms Project. And just to illustrate the problem that we face, here it is of great interest for us to be able to apply methods of quantitative electrophysiology. Just as a reminder, And this is the, let's say, the most advanced of our applications, and it is also going to be available on CBrain and EEGNet. The electrical activity of the brain is processed using, for example, spectral measures. These spectral measures are collected from a large data set over the lifespan, and normative databases are created, and norms are created against which individuals can be compared. This is work that was carried out during decades since the 90s in Cuba. One of the examples of data sets is the Cuban Human Brain Mapping database, which was published in Nature Scientific Data. This is a multimodal data set prominently using EEG, and it is available on CBrain and EEGNet. This effort has been expanded, and we now have a global EEG norm project, which has representatives from 9 countries with extensive pipelines that allow the creation of norms, the harmonization of EEG data. And all of this is an example of the type of effort that has to be carried out, in which we need to be able to collect data, as I say, to upload it, to analyze it, and then to have the workflows that people can use to analyze this sort of data set and then adapt it to their own conditions. Prominently in this effort, we have joined forces with the International Federation of Clinical Neurophysiology, the eminent clinical neurophysiologist Paolo Rossini, who is one of the directors of this international federation, is now a member of our steering committee. We are committed to doing different efforts with clinical neurophysiologists around the world, such as, for example, crowdsourcing the annotation of artifacts. And the way to do this is to use the standard terminology of the International Federation of Clinical Neurophysiology, and Scott McCaig's group has advanced considerably in, headed by Kay Robbins and Dora Hermes and Nepal, who have been working. This team has been able to implement this in a hierarchical event descriptor, which has given a formalism to this type of standardized annotation. So basically, as you see, there's the problem of uploading data, the problem of harmonizing and annotating the data, the problem of providing analytics to create norms and do harmonization, and then to apply it to measure abnormality. Now, there's currently no or not many general systems that allow in an open source manner for people to do this work around the world. And it is precisely EEGNet that plays an important role of creating the infrastructure to allow all of this, as will be explained by Christine, who will now takes the floor. Thank you.
Thank you very much, Pedro. I'll just begin sharing my slides in one moment, and we'll get to the what you've all been waiting for in terms of the introduction to the EEGNet platform. So I'm going to introduce some of the context from the grant. Can everyone see my screen okay? Let me know if not. Let me just share that. We're okay? Great. So as an introduction to the platform, for which Pedro and Alan set the scene so nicely for the grant and our collaborations, and also to invite everyone, in advance of inviting everyone to log in on eegnet.loris.ca, I'll begin. So I'm going to cover the grant context, getting started, including how researchers can participate and contribute data sets and tools, and then proceed to a video demonstration, including how you can request an account. So as Alan covered already, the vision and the outcomes for EEGNet were to provide a unified platform to end up building collaboratively as a community, gold standard, expert annotated, open EEG data sets that are BIDS compliant with the brain imaging data standard that would be hosted on the EEGNet platform and then be ready for machine learning clinical applications and translation for early identification of biomarkers. Through the 4 aims or pillars of building a data platform with open EEG workflows that are BIDS compliant, supporting data sharing, and providing an analytics hub through the CBrain platform. So special thanks to the groups that have supported us, including the PIs who have been part of our governance and our oversight committees, including especially the technical committee that has been meeting monthly to advise on what should be built, how it should be built, and how some of this work should be prioritized. The team as well, who's here on the call today, the EEGNet working group, have done very impressive work leading up to this launch, and we're very pleased to present the culmination of this work to you. So if for the scientific and clinical context, we'd also like to invite you to visit our YouTube on the Global Brain Consortium channel for a recap of the virtual colloquium that we held in May, in which we had talks that went more into the scientific and clinical and informatics context. And as Alan mentioned, we'll also be following this up in early 2024 with additional scientific talks. So some of the context for this work is that over the past few years, we've developed open science projects using EEG data through our informatics platforms and databases, including visualization tools. One notable one is the MNI Open EEG Atlas with Dr. Birgit Frauscher and Jean Gottman. This was released several years ago, and it will be followed up by the IEEG Sleep Atlas. And in addition, the Cuba Human Brain Mapping Project, which Pedro has mentioned and is available open now on one of our LoRa's instances and is linked to EEGNet. This was another early project to demonstrate EEG visualization through an online web-facing portal into which users could log in and visualize, query, download data, including imaging, including EEG that's BIDS compliant, including cognitive and other demographic and clinical factors. So in the context of EEGNet, this grant began in 2021 in plein milieu, as we say in Montreal, of the pandemic, with a grant launch event. We have had several delays across sites, including at our partners Brock and Laval, due to the challenges of operating a project at full steam during a pandemic. These include staffing and resourcing. So in this timescale, we'll also be seeking an extension from Brain Canada to continue work on this project within the context of the original grant. But to date, what we've done is launched a pilot data platform with a data hub, online workflows, data sharing, and analytics per the pillars of the original grant plan. And where we're at right now in the fall of 2023 is the platform launch with addition of more data and more tools on the analytics hub on CBrain. The metrics to date include that we have 7 open data sets, which is we're looking to increase with the help of the community and your contributions. This comprises 500 recordings to date. We've got a significant group of test users, and today we'll be inviting more of you into testing the platform with us as part of this technical preview. And we have 4 analysis tools mounted on CBrain as part of the EEGNet Analytics Hub. As well, we've given numerous conference talks and presentations, including a featured talk at the Organization for Human Brain Mapping Conference this past year, at the Neuroinformatics Assembly, and as Pedro mentioned, at the International Clinical Neurophysiologist Conference. There are 3 papers already out and many more manuscripts in the works. Additional resources that we've already contributed and released include on eegnet.org, our public-facing website, the tools and data sets that researchers have shared information with us about. We've released that information and provided links, and where they are already available on the EEGNet platform, on CBrain, and on the Canadian Open Neuroscience platform. Those are also linked. So we certainly invite you to tell us more about more of these tools And let us know more. Let us know your updates as well about these tools if you have already contributed information to us. So moving on to the actual platform, as Alan mentioned, EEGNet is combining data platform with online workflows, data sharing and analytics, sits upon Loris and CBrain, which are a data and analytics hub combined and linked through workflows and toolkits that are online. So through this, data is ingested with the help of tools that enable it to be standardized and prepared to comply with formats such as the Brain Imaging Data Standards, or BIDS. And then as they're ingested into the platform, they're pre-processed and can be annotated, queried, filtered, exported, and processed, and disseminated to platforms such as the CONP and NEMAR. And the idea is that through the collaborative efforts of the community in annotating and validating these data sets, we will be building gold standard data sets for applications in machine learning and global health. So for those who've been following our progress lately, what is new and what is ongoing for the current moment of this launch is that we've added to the dashboard project information and interactive display graphs, which we'll show you in the video in a few minutes. There are EEGNet tools and data sets with links to the CBrain Analytics Hub and tags that can be linked on an event type across an entire data set using the head and score ontologies. As well, users can tag a single event with a score artifact or a pre-marked head tag that's already been applied in the same data set. Work we're looking forward to delivering in 2024 includes applying events and tags onto individual channels, since at the moment you can mark a segment of time across all channels to indicate an artifact or a head tag that you'd like to associate with that. Also, the ability to create and remove events and to select from even more ontologies and broader tag sets in every workflow. As well, we're looking forward to adding version, tag, and dataset tracking so that the provenance and the granularity is very well auditable and very clear and transparent. And adding workflows so that researchers can request access to data, request to validate and to annotate data sets, and to enable the PI owners of each data set to control that process as well in terms of upload and access. We're also, as mentioned before by both Alan, myself, and I think Pedro, looking to engage with you, the community, to bring more data sets and tools to this platform. So that is a key priority for us moving forward. So as Alan mentioned, the Loris and CBrain relationship is built on open source infrastructure, leveraged also by the Canadian Open Neuroscience Platform, where a data hub and an analytics hub work together to store and process data. This means that we've built this on open source software, the Loris platform, which has many, many layers and a great team, some of whom are here today, who contribute this code to the world for many different projects. And the CBrain team as well, who also build the processing portal as part of our team at the McGill Center for Integrative Neuroscience. Some of the tools that we've added on the CBrain processing platform are part of the GBC community as well. Jorge Busch-Bayard's notable harmonized QEEG toolbox, which together with Min Lee and Ying Wang is one notable tool. This is an example of an EEGNet core toolbox that's been developed collaboratively with our GBC partners and is now available on CBrain and is linked to EEGNet. Another tool developed through the EEGNet grant is the Brainstorm tool, which Corentin Labelle has been developing at Laval at the Cerveau Research Institute with Philippe Albouy, building on, of course, Sylvain Bailly's Brainstorm suite to encapsulate it and to put pre-processing pipelines in a user-friendly way that can be deployed automatically on clusters through CBrain into kind of a prepackaged model for rapid deployment. So coming back to the overall integrated hub and the big ecosystem picture, this is how these pieces fit together in order to provide a data platform with online workflows that support data sharing and analytics, including tools such as the harmonized QEEG toolkit and the Brainstorm tool. have additional EEGNet tools that are both on CBrain already, such as the QEEG toolkit, and as well one that is just being added this week through the work of Scott Huberty, James Desjardins, and Tyler Collins, the Pi lossless pipeline, which we're very excited about coming online, I think today, in fact, on CBrain. So in addition to this, we provide tools to allow researchers to prepare their data, since many come to data standardization and the brain imaging data standard, or BIDS, for the first time when they come to EEGNet. So for this, we provide an EEG to BIDS wizard tool. We're currently supporting EDF, and we believe we have a fresh version that supports SET as well. And we've been working closely with the MNE-BIDS community to use the open MNE-BIDS libraries packaged on a GUI tool so that any Windows user, for example, can, within a few clicks, prepare, package, standardize their data in a way that's robust, well-documented, and compatible with databasing it in EEGNet. This is a separate open source tool that we released to the community, and we're looking forward to providing updates to that, on that to you in the community. Supporting, of course, the data sharing effort and data standardization efforts. So how to get started? This is where we'd like to reach out to researchers who may have data sets or tools that they would like to contribute to the EEGNet community and just to the research community in general. So the first step is to visit eegnet.org and to perhaps consult our datasets and tools page to see what's already there, but as well fill out the brief online forms there, where we ask not only for your input on the direction of EEGNet, but also for you to let us know a few details about any data sets or tools that you think you would be interested in contributing. Once you've done that, basically we get in touch and we keep in touch and walk through the following steps. So it's up to you, of course, as a researcher, to select how you want to share your data or your tool. There are a few things that you need to determine, such as what you can do, and this is, of course, governed primarily by ethics in the case of data sets and consent of your participants. But also there's a question of what do you want to do with the data set. So one option includes sharing via the EEGNet platform, which facilitates the visualization, the analytics, and the annotation, as you'll see shortly in the video. And other options include sharing via the Canadian Open Neuroscience Platform portal. So through this, you can get in touch and prepare and send us your data, and we can walk you through many of those steps. And one caveat is just that we do recommend that data sets be released with a license that's CC BY, where citation can be required, but enforcement is up to the community. So we cannot guarantee authorship, though it can be a requirement of use. So in terms of what you can do with your data, as I mentioned before, ethics is the primary consideration, and for resources and evaluating what the potential might be, you can consult the Canadian Open Neuroscience Platform Ethics Toolkit, which is undergoing updates as we speak. And then it is up to you to determine effectively what you want to do with your data. For example, if you'd like to contribute your data to a platform where it's downloadable and browsable, but also with visualization on an accessible collaborative platform where it's queryable together with other data sets, where you can perform interactive quality review, where it can be data-based with multimodal data such as imaging or clinical demographic data, and where you can tailor and customize the data citation policy, then that might be a sign that EEGNet is the platform you're looking for sharing your data. And we are in a position to kind of walk you through many of those options and considerations. So with the EEGNet, you can visualize, annotate, and enable community annotation, as well as analyzing data with the tools mentioned, as well as many more on CBrain on the high performance computing clusters, as well as on the Canadian Open Neuroscience Platform. You can share the data similar to as you would on OSF or Zenodo, and simply list the link on the Canadian Open Neuroscience portal, or you can also ask the Canadian Open Neuroscience portal to host effectively a zipped package of your data if you need a large physical site with custom metadata, for example. You can also link through it to with DataLad. So as a step, to go back over the step about preparing and sending us your data, We have converters, which I've mentioned before, the EEG to BIDS tool, which will help standardize your data. We have uploader tools and SFTP systems to facilitate the data transfer. We have metadata templates where we ask you for structured information about your data set and the provenance. And we also provide walking through of the boutique's descriptor templates for tools that will be containerized onto CBrain. Throughout this, you should have no problem reaching us at the email below. We'll also have open hours starting in December, and there'll be more information about that at the end of this session. So thank you to the team who's here today, the EEGNet working group, to our advisory groups, and as well to the development team at the McGill Center for Integrative Neuroscience, including our technical director, Samir Das, and our colleagues at the Global Brain Consortium who provided so much input and support. And as well, thank you to our sponsors. So with that, we're going to move on to the video demonstration. So thank you for your time today. And we will play a brief video showing the features of the platform at eegnet.loris.ca.
Welcome to EEGNet, an open platform for collaborative EEG-based research. On the EEGNet platform, you can access, query, download, and annotate standardized EEG-BIDS data. To request access to EEGNet, click the link to request an account and register to receive an email with your login credentials. Remember to review and accept the terms of use before you log into EEGNet. The dashboard summarizes the data sharing and analytics resources and workflows available through the EEGNet platform hosted on Loris, an open source database built at the McGill Center for Integrative Neuroscience. Recent activity on EEGNet analytics tools mounted on the CBrain distributed processing portal are displayed in the top right corner. A visual breakdown of the datasets or projects gives different views of the composition and size of data available on the EEGNet platform. Click on the label of a dataset to learn more in the project information panel below, including publications, how to cite this dataset, and task descriptions. To view the EEG signal data, click through or use the menu bar to access the electrophysiology browser to view the session recordings from any project dataset, raw or derivative. All available recordings can be reviewed in the electrophysiology browser module. Search for the recordings of interest and select the dataset type in the links column, raw, derivative, or both. For a single session or visit, scroll down to view the signal plot and its interactive features, metadata, and a basic electrode map in 2D or 3D view. All downloadable files are available under the signal plot. Within the signal plot, zoom in to a specific time segment, or step forwards or backwards through the recording with the arrow keys. You can enter directly which time code to view, or manually adjust the visible time window using the timeline sliders. Press Reset to return to the default time range. Press Show All to see the entire recording. You can view more or fewer channels and move through the channels one screen at a time. Hovering over a signal shows the value at the selected time. Hovering over a channel name highlights the channel. You can also adjust the signal's amplitude or apply filters. The stack feature overlays all channels in the current view on a single axis. Click Isolate to display one channel at a time. Use the Help menu to learn tips and shortcuts for navigating this module and its many features. From the left column of the page, the Dataset Tag Viewer can be used to map event attributes in a dataset to specified head tags, assigning them to every event within a given project with a particular attribute. Select an event attribute pulled from the dataset's event files, select an attribute value, and then search for tags to associate to every event instance in the dataset with this attribute value. Tags can currently be selected from the hierarchical event descriptor schema as well as the SCORE clinical epilepsy schema. More information on each tag in the head or SCORE ontologies can be viewed on screen, or by clicking to the online head schema resources. Multiple tags can be added and grouped together, for example, to describe the characteristics of a presentation stimulus. Note that changes made in the dataset tag viewer are immediately reflected in the event panel across the whole project dataset. When viewing one EEGNet recording at a time, you can use the interactive signal plot to review and edit recording events and tag specific events for all channels of a recording with specific head or SCORE tags. Click Show Event Panel to view all the events in the current viewing window. Press the I button to hide and show events. The Tag button shows any head tags associated with this particular event. Press the third button to edit the event. Hover over head tags to view additional information. You can add and remove head tags already used on this dataset and SCORE artifact tags with this menu. The Data Query tool provides an easy-to-use interface for querying, downloading, and exporting data available on the EEGNet platform. To start a new query, click Define Fields to begin building the fields for the query. Fields are organized by categories such as demographics and EEG data. You can also define filters for your query in the next section. Click Save if you would like to rerun your query later or make it visible to the other users. Click Run Query to view your result in the data table, which you can download as a CSV file. Click Export Results to CBrain to create a list of file references that can be used with CBrain. Upon clicking the button, you will be given instructions on how to generate a fresh access token from your CBrain account. This token must be copy-pasted in the field below the instructions. This generates a link to CBrain to access the file list returned from your query, which you can then run tools on. Help us improve EEGNet by giving your feedback via the issue tracker. You can also identify issues with datasets or give feature suggestions using this tool. To get started using the EEGNet data sharing and analytics platform, go to eegnet.loris.ca and click Request an Account to begin.
All right, thank you very much. That was the voice of Jefferson Casimir, our lead developer, working with our software. So I think you can see the effort that the EEGNet team has put into delivering this platform, and we're very excited to show it to you all very shortly. So that brings us to the end of the platform demonstration. Next slide, please. All of these slides and video will be available after this session with the recording. We'll be putting it on YouTube of the GBC, the Global Brain Consortium, I believe, and as well we'll link it from our site, eegnet.org, both for those who missed the session and as well for review at your own pace. So no worries there. So at this moment, we'd like to invite everyone here who is part of the research community to request an account on EEGNet. And to do that, you follow the simple steps on screen. Go to eegnet.loris.ca and fill out the request form. We do recommend you use Chrome. That is how it's designed to perform best. And after you fill out the requests and accept the terms of use. In short order, you'll receive a login in your account, in your email. And after you reset your password on first login, you'll be in the EEGNet platform. For the moment, for December and November this year, we've limited some of the head annotation tools to work only on the phase 13 project. So we invite you to try those out on that particular data set. And in addition, if you do not already have a CBrain account where the EEGNet tools that we've discussed and where many, many other workflows and analytics tools are available for processing data on the high performance computing clusters. If you have not already set up a CBrain account, we invite you to do so by going to portal.cbrain.mcgill.ca and requesting an account there. And as we've demonstrated in the video, and as we can walk you through again, when we release the video, you can link that seamlessly with your EEGNet LoRaS account. So next slide, please. We also invite you to reach out to us through many means, since we'd like to hear not just community feedback and community input on the platforms through the surveys and the forms that I mentioned earlier, which are available through the EEGNet.org contact page. But also please do, or don't hesitate to reach out to us at contact@eegnet.org by email. On the platform, as you just saw, there's also an issue tracker if you'd like to let us know about an issue you see with the data set or some other issues that you spot. We are still working on some of the features in development, as I mentioned, including optimizing some of the loading time for some of the signal display aspects in the browser. But do let us know if you spot anything exceptional. We will also be having office hours on Zoom. So virtual open office hours, Tuesdays at 2 o'clock, starting December 5th. We'll be putting the schedule up at eegnet.org on the contact page. So check in there and come ask us questions. We're certainly there to help people prepare data, answer questions about the platform, and help walk anyone through any of the topics that we've covered so far. As well, we'll be releasing additional material in the time to come, not just new features on the platform, but also this video release, additional videos, and with a short FAQ guide and additional user guides, both for those using the platform and for those contributing data and tools to EEGNet. So with that, let's go back one slide and just bring up again the information for how to request account on EEGNet. And we will also invite you at this time to use the chat, as Alan mentioned at the beginning, to ask us any questions for the platform or for any input that you'd like to provide. So with that,
all feedback gratefully received, both positive and negative, what you like, what you don't like, and what you'd like to see as a priority in the development going forward.
Great. Iram, if you could go
You
forward.
can raise a hand and I will pass your question forward.
So one question that we've gotten in the chat is from Nicholas Whitridge. Is CBrain available for researchers who are not currently affiliated with any academic institution? Alan, is this a question you'd like to respond to?
Oh, sorry. Is available for research who is not currently affiliated with an institution? Well, I think it would have to be evaluated on a case-by-case basis. You can't just make the data available to anybody without some kind of reference or some kind of credentials. Obviously, that's normally provided by a university, but if someone is not affiliated with the university immediately, then I think you have to assess what are their credentials. That would have to be assessed on a case-by-case basis.
I think our primary consideration as well is the ethics governance, which is limited typically and mostly universally to research applications with data sharing when that is available. So that is a primary consideration in some of these access principles.
one of the issues that often does come up is are the analytics, the results of the analytics reinserted into CBrain? Where do they, into Loris, sorry, where do they go? Presumably, some people do not want to have their data in a Loris instance, so can they make use of CBrain and get the results back on their own server? The answer to that is yes. There's another question from Nicholas. Is there any incorporation of ERP data within the database?
So that's a great question. What we do with the data representations that we ingest and store is that we follow the BIDS standard for EEG data. So as ERP data becomes part of the BIDS, and this is the brain imaging data standard representations, we broaden support for those representations in the data. So right now, researchers are very welcome to include ERP data. And for example, if you have imaging data with your data set, which is in the case of one Laval Cerveau data set that you can see on the platform, you're free to upload and send us your imaging scans, and those will be available to researchers. It's the same with ERP data. It can be included with the data set. However, to be queryable across the database, it has to be effectively represented in a BIDS compliant standardized form. So there can be incorporation of ERP data as soon as we have a researcher who would like to contribute a data set and share that through the platform. Whether it will become queryable and across data sets, for example, will follow the sort of the global standards of the community as those evolve. But currently there's no barrier to adding ERP data with your data set in the database.
It's perhaps worth pointing out that it is not a huge lift to move from EEG to ERP or to any electrophysiological time varying signal. It always requires a little bit of pre-processing, data processing, but the data itself, of course, if you can do EEG, you can do pretty much any time varying signal. A little bit peripheral to this initiative, but we are working with our colleagues in Ottawa who are working in a heart context, and of course then you can make use of EKG and other kinds of heart related time varying signals.
Absolutely, and the applications across similar electrophysiology fields are very much easy extensions for this platform. There's some discussion of intracranial EEG, for example, and future extensions for MEG data are also something that are considered as researchers bring our data sets to contribute. I see one question. I see a certain Samir Das in the audience.
Yeah, thank you. I'm actually walking around outside, but I'm just wondering about what the plans are. As you know, electrophysiology data is not the best formatted in terms of standardization. So there is this push for EEG-BIDS, and we have our EEG-BIDS wizard, but there's many different formats that we're trying to incorporate in it. What is your thoughts on the next realm of formatting? So that we've handled EDF to some degree and .set to some degree and so on and so forth. What is next on the horizon?
Yeah, I think it's a very interesting question. Currently, BIDS, the Brain Imaging Data Standard, supports 4 major formats, and we're certainly looking for those I'll say platform, but what I mean is the collection platforms, so Brain Vision, Biosemi, et cetera. Those who are really defining data types to work together and to really come together for enriched, so not lossy, and interoperable and cross-compatible data definitions. It's always a balancing act, of course, with the standardization community to not exclude too many practitioners and to be as inclusive as possible. But until we have convergence on one data standard that everyone's happy with, which is a challenge in any field, I think we'll continue to see several supported. And so our goal in running platforms like this is to support the major types as inclusively as possible, but with a robust and sustainable approach effectively. So to that end, we support tools that we've created like the EEG to BIDS converter which was started with EDF data and has been recently increased in scope to encompass set data, not just FDT set, but also just set with HDF5 support, and that we expect more news on that soon. But approaching sort of broadly but strategically the supported data formats is an approach we sort of have to take, keeping in mind the resources that we have available for as we develop these platforms.
Thank you.
Any other burning issues? I'm going to take the opportunity to just bring in Sid Segalowitz and Philippe Balbouy. Sid, Philippe, the issue that sometimes comes up here is that people are not entirely sure about putting data in the open space. Would you like to just represent the user's perspective? Why would I put my data in the open? What are my concerns about doing that?
Sure. The obvious first concern is somebody going to be able to make use of my data before I have a chance to make use of my data? Obviously, we have to protect ourselves. But there are a number of ways to provide the data in a way that can help the community, and including ourselves, when someone else uses it in a way that's compatible with our goals. So, for example, we're collecting developmental data on children with and without clinical concerns, and we have to protect their identities, and of course, but what we can do is simply present, make available the data that's anonymized. There's no clinical details given because that in some way could be used to track down who the individuals are. But the data are still generally described as representative. And if somebody else had more data like that, we could then be pooling a much larger caseload, which of course would help everybody. Does that get at what you're referring to?
Thank you very much, Sid. Philippe, you have any thoughts?
I would have one comment that is more technical, that when you want to share your EEG data, first you need your ethics for that. First and second, you have to prepare your data so it can be used by the community. So the problem is that with EEG data, a few months ago and a few years ago, we didn't have any support for that or any help for standardization and everything. And what is, I think, the two very important features of EEGNet for sharing data is that EEGNet community can help you first for the ethics to obtain the authorization to share your data, but second, to share it in the standardized format using the EEG-BIDS approach and using the open hours of EEGNet. Then you can really be supported by the community to prepare your data in a standardized format. So I think that's the really main feature that will help, because one of the main limits of sharing EEG data is preparing yourself in the format that is appropriate for the community and everything. So I think that's one of the really main, very big advantage for data sharing of EEGNet, that we are here to help you share your data.
Thank you very much, Philippe.
Can I just mention one other thing? We went through some discussion with our ethics board concerning data that we've collected some time ago when we didn't think about EEGNet being on the horizon and that sort of thing. And so we've worked through with them what to do about when we've never actually asked the participant whether we could share the data. And the conclusion was that our tri-council rules would permit this as long as it is really anonymized entirely, and it would be impossible to, you can show that it'd be impossible to track everyone down, which of course is the case if university students have left and they've gone off somewhere else, we don't know where they are anymore. But you have to clear this with your own ethics committee, because different ethics committees have different levels of understanding sometimes.
Absolutely. I'll just add, especially as a link in the chat, one of the important points of connection with the Canadian Open Neuroscience platform that we have is their ethics toolkit, which provides a great roadmap to researchers who are navigating exactly these issues. Sid, as you said, it's very specific to your local context. So sometimes the guidance we provide has to be generalized, but we've had great development from the Canadian Open Neuroscience platform of this ethics toolkit that we certainly recommend to the entire community as a resource as part of EEGNet.
I see that Scott McCaig has raised his hand. Scott, of course, heads the NEMAR EEG platform. Scott?
Yes, I'd like to speak to the broader and future evolution of open science and data sharing, and that is, I think increasingly as the power of computation is certainly demonstrated by now, that the ability to extract new information using new technologies that are have been invented and available to a few or will be invented is increasingly important, and so the reward accruing to experimenters has to be that they've contributed important scientific data sets that lead to progress in science in the future, past what they were their particular aims in analyzing their data. So as I think this sort of represents a sea change in experimental science, that the rewards from collecting data and analyzing data don't end with publication of a paper on the data, but they can lead to continuing rewards career-wise for the investigators if they in fact contribute useful and well annotated and analysis-ready data, which I applaud the EEGNet project as a for featuring and for explicitly aiming for.
Yeah, I couldn't agree more, Scott. There is definitely a philosophical changing of the guard taking place with open science. A young researcher's career can be catapulted into the stratosphere if people around the world start using their data and publishing their data. We still have work to do to convince the promotion committees of the importance of a data paper. But that battle is being won. As the younger generations are coming through onto promotion committees, they recognize the value of an open data set to science and into society. So it's taking moving in the right way. I completely echo Scott's perspective on this. Scott, maybe I could ask you one question. How do you see the complementarity between NEMAR and EEGNet?
Well, I mean, NEMAR, we should say, is technically the front end for electrophysiology data to the Open Neuro repository at Stanford, or run out of Stanford, and but both use BIDS, both use head and score tags to describe the data, and so I don't see that there's there really should be any difference. I would like to see them harmonized in that where the data comes from is worthy of citation, but shouldn't be the main point. And so I would hope in the future we could harmonize, and not just between US and Canada, but other countries as well, Europe, Asia.
Yeah, absolutely. Within the context of GBC, that's precisely what we're looking to achieve. And I think there's a lot of work to be done to harmonize under the hood. It shouldn't be that difficult, given that they're all based on EEG-BIDS.
Mm-hmm.
All right. It's 4 minutes past 1 o'clock, and we had intended to restrict this to 1 hour. So I think we're pretty much at time. I think this has been very informative for us, as well as I hope for the people on the Zoom call. By all means, do provide more feedback through the eegnet.org website, the linkages that Christine provided. All of these talks are available for you to look at your leisure at a later date. And please do provide us with feedback, and preferably data and tools as well. The more we get, the more momentum the whole project gets. So that's all from me. Christine, would you like to make some final remarks?
Just say thank you very much, and we look forward to hearing from you with your tools, data, and your questions about the platform. Alan, I think we've covered it all, and thank you very much those who brought questions. We're certainly open to hearing more from you very soon.
I would like to thank Irem Katitis, Derek Lowe, and Jefferson Casimir for all of the work they did in setting up this website, providing the video, and just managing the whole process. So thank you very much, everybody. And of course, to Christine for leading the charge.
Thank you.
Thank you very much, everybody. Bye-bye.